Greetings. Welcome, everyone, and thank you for joining us today. We're going to just get a few more minutes for people to come in, but in the meantime, I'd love for you to put in the chat where you're joining us from. You can either put your company and your country. Say hello to us. We want to check in with you, see how you're doing, and furthermore, thank you for being a part of this webinar today. I also want to thank the guest speakers that we have. I'll tell you more about them in a minute, but today's conversation is around commercializing SMRs, and we'll have industry perspectives on advanced nuclear. As you all know, we have been doing so much, not only in the United States, but globally, and it's amazing for us to be able to have such a forward leaning conversation around nuclear with our trusted partners and friends. Before we get started, I do want to go over a few housekeeping rules for the use of the Zoom today. This webinar is being recorded and will be shared after the session. So there will not be any additional slides sent out. So you should not ask me, are we going to receive the slides? Because guess what? They will be in the Zoom recording, which you will all receive. So you will have the entire webinar, not just the slides. You are automatically muted upon joining the webinar, but you may use the chat feature to add your inputs and questions and also the QA box to ask questions. So you have two opportunities there. I see all of the countries, cities, companies joining in. I'm so glad to see so many folks this morning. I hear the registration was well above 350. You all are really showing up for our communication series that we've done over the past few months. This is amazing. So let me continue to tell you that you may adjust your audio through your audio settings or find dial-in information on your registration email. And then finally, we will have a survey at the end of this event. We appreciate and welcome your feedback to these sessions. So please take a few moments to fill out the survey at the end of today's webinar. So for our session today, we will be joined by GE Vernova, Westinghouse, NuScale, and Kairos. And so we are excited to welcome these speakers. They are either chief nuclear officers, chief technical officers, or chief operating officers in the company. We even have one who is also the co-founder, Jose Reyes of NuScale. So these folks are of such a high caliber that they represent the enthusiasm, the knowledge, the vision, and I think the most holistic view of what the company is doing, why it's doing it. And so I'm honored that they will be with us today. So let me pause just to tell you a bit about what Nice Future is, so you have that understanding as well for those of you who are joining us for the first time. The Nice Future Initiative is the only nuclear initiative of the Clean Energy Ministerial, which is affectionately called SEM, and it leads the global conversation of the role that nuclear energy plays in energy systems of the future. And we recognize that there is no one size fits all to all of the energy challenges. So Nice Future brings together government, private sector, NGOs, and others to explore the role of advanced nuclear technologies in supporting reliable, affordable, and secure energy systems worldwide. So this initiative, Nice Future, has a few strategic objectives. We bring the nuclear energy from traditional nuclear only fora to broaden the multilateral discussions. And that's important because oftentimes in the nuclear space, we say that we have to stop talking to ourselves. That means we have to broaden that conversation in a renewables context, in an aerospace context. The list goes on and on. So we want to make sure that we are explaining to folks how nuclear plays a role in so many different parts that make up a normal quality of life. People experience that in medicine and food, and the list goes on and on. So that's why we have this important crosstalk, cross sector, and multilateral conversations that really hit home in that way. The next is to engage both nuclear and non nuclear energy policymakers and stakeholders in discussions on the role of nuclear energy in reliable and affordable power generation, advanced reactor deployment, and supply chain development for energy systems of the future. And then the final strategic priority is to ensure that policymakers are informed of the opportunities and challenges to meet global energy goals, covering areas of technology feasibility, economics, financing, stakeholder engagement. So, with that, I'd love for us to turn to our agenda so that we can jump right in and tell you what we have in store for you today. For our session, we will first turn to Kairos Power. We will then move to GE Vernova, followed by Westinghouse, and then finally we'll hear from NuScale Power. So after that, after each speaker has provided their own individual remarks, we're going to have 30 minutes to ask some questions in a panel type forum. So of course, I have some questions already, and I do want you to put your questions in the chat so that we can get to your questions as well. We want to have as many of your questions answered as possible because you are our superstars as well. And so I'm going to try to manage to make sure that we can keep the conversation moving and get your questions answered. So first, let me start with our first speaker. We are delighted to be joined by Dr. Ed Blanford of Kairos Power. Dr. Blanford is the first speaker, and he is the co-founder and chief technology officer of Kairos Power, where he leads all engineering and technology development for the company's advanced reactor program. He oversees KPFHR designs and analysis, major hardware demonstrations, internal manufacturing programs, fuel and salt supply infrastructure, construction management, environment, safety, and health, engineering options, and licensing strategy for the company's future fleet. Dr. Blanford holds a BS in mechanical engineering from the University of California, an MS and PhD in nuclear engineering from the University of California, Berkeley. He serves on the advisory boards of the nuclear engineering programs at the University of New Mexico, Texas A&M University, and University of Tennessee, Knoxville. What an amazing resume. What an amazing person to start us off. Dr. Blanford, I'm excited that you're here. I'm so grateful. I've seen the wonderful work that Kairos is doing. You all have just done some incredible work. I've even held one of the pellets in my hand. And you have the best comms person ever because Mike Mueller used to be at the Department of Energy with us. We're so excited to welcome you today. Thank you for joining us. Let us turn this over to you.
Thank you for the introduction, and I couldn't agree more around Mike and appreciate the kind comments there. I presume you can see my slides, Aleshia, is that correct?
Yes, sir.
All right, thank you so much, and good morning, everybody. My name is Ed Blanford. I'm the co-founder and CTO of Kairos Power, and really pleased to be here and talk a little bit about what Kairos is doing and join in the panel discussion. Kairos is a mission-driven company. We start all of our presentations off with our mission statement, and that's to enable the world's clean energy transition to improve people's quality of life while protecting the environment. And really, to achieve this mission, we are focused on delivering a technology that's both safe and affordable. Just a bit of an overview around the company itself. We're a nuclear engineering, design, and manufacturing company, and we are focused on a singular technology. It's a bit of a mouthful. It's called the fluoride salt-cooled high temperature reactor, FHR for short. We believe we have a novel approach to our development that really focuses on an iterative development process and really bringing vertical integration to where we feel it matters the most. We are driving towards U.S. demonstration by the 2030s. We believe that's important for getting electrons on the grid, but we are looking internationally beyond that. Like many of our competitors and colleagues, our cost targets are not to be, competitive with old nuclear, but really to be competitive with natural gas in today's U.S. electricity market that's very much evolving and changing. We were founded in 2016, and I'll talk a little bit more about where we have locations. Starting first on the commercialization side, as I mentioned, the technology, it's called FHR for short. It combines two historic technologies that have been used actually in different applications. So we combine the high temperature coated particle fuel, commonly known as TRISO, working within the specification that the Department of Energy irradiated and tested this fuel around. And then we combine that with a high temperature, low pressure coolant called FLiBe, which was historically used in the molten salt reactor program, which is really a combination of lithium fluoride and beryllium fluoride. We have combined these two technologies because we believe it gives us a unique safety case that opens up a lot of opportunity in how we design the reactor systems, but as well as achieving economic goals around the reactor building and the civil structures, which really dominate a lot of the overnight capital costs in today's technologies. As mentioned, we're very much big fans of iterative development, which means getting to the final thing, which is what many people want, which is grid scale commercial deployment. It's actually through a number of iterations that are smaller steps that get you there. Why do we do that? We believe it allows us to get input into the design, confidence in the supply chain, and really achieving that cost certainty that our customers are really asking for. And so by doing a series of iterations, we're able to get that feedback early into the process and really break down these long 30-year commercial timelines that take, nuclear technologies from infancy all the way through to deployment. We do that through a series of non-nuclear iterations, what we call our engineering test unit series, and I'll talk a little bit later about those. Going into our Hermes nuclear plant series, which is the Hermes low power demonstration reactor and the Hermes 2 demonstration plant. And then through that, through standardization, achieving really the commercial grid deployment opportunities. Where are we located? We're headquartered in California, in Alameda, off of the old naval base. That's where we started, really building out of the UC Berkeley history, where DOE funded the integrated research projects that really enabled Kairos to be formed. We have a site in New Mexico. I was a professor at UNM, so I have a history there. The manufacturing development campus is located in Albuquerque. That's where we really do a lot of our large-scale manufacturing, our module development work. We have commitments around both salt and fuel infrastructure and supply chains. So we have our salt production capability as well as our TRISO development capabilities. And it's where we do large-scale manufacturing and testing. We have a partnership with Materion. As I mentioned, we use a coolant called FLiBe, which uses beryllium fluoride. Materion produces a lot of that material, and so we partner with them in terms of producing our salt production. Last but not least, we have a site in East Tennessee, in Oak Ridge on the former K31, K33 enrichment facilities, which is a brownfield site that Kairos has repurposed really for our Hermes demonstration series. So it's really a combination of all of these sites that are enabling for our deployment strategy. There's been a lot of hard work that's gone into building up these capabilities. I mentioned manufacturing. Early on, there was a recognition that the supply chain that we wanted didn't quite exist. And so rather than make investments in standing up that supply chain where there were gaps, We made commitments really to bring in manufacturing. I'll talk a little bit later about our vertical integration strategy, really around steel manufacturing and graphite manufacturing. I've got some pictures of some of those capabilities shown below. The U.S. has been a little bit dormant in terms of some of the nuclear manufacturing needs. Because we're a high temperature, low pressure system, we usually use thin walled vessels, which are different than some of the light water reactor technology needs. And we made a lot of investments in really standing up that capability. That capability largely resides in our Albuquerque campus, but we are standing up capabilities in Tennessee as well. And I'll talk a little bit later about what drives our decision making on where we focus those activities. Um, Coming right to that, the vertical integration strategy, we've really focused and emphasized investments on really parts of the supply chain that are three features. They're salt connected. So if it's something that we have to qualify in this high temperature FLIBE environment, we've made commitments around that. If it's safety related, it's important to the regulatory safety case. And perhaps most importantly, if it's not available. If it's available, our preference is to move in that direction. If it's not available, we need to have confidence that material or those components will be available for commercial use. And our engineering test unit series, which I'll talk a little bit later about, has been a very useful vehicle for determining can suppliers really perform under the needs that we have. So if you look in the lower left, as I mentioned, if it's safety related, it's all connected. So that really brings in a lot of the reactor component manufacturing and modular system construction, as well as really investments around fuel and molten salt coolant. We would love to be able to buy FLIBE at volume, but commercially that material is not available. So rather than depending on someone else to produce it on the timelines that we need, we have made commitments around that coolant. That also gives us a lot of control over owning the specification around the coolant and ensuring that it meets our quality requirements. And while there are capabilities out there around TRISO fuel, fuel is so central to our commercial case, and we do have a slightly unique fuel form. So we've made investments around fuel production as well. And so coming to fuel itself, we've been doing a lot of work in Albuquerque because we need pebbles for our engineering test unit series. We made a fair amount of investment into automation of large volume manufacturing of fuel. And so while many people start from the kernel going out to the particle to the fuel form itself, we focus a lot on the pebble form itself and developing some innovative manufacturing capabilities. We have a partnership with Los Alamos National Lab at their LEF facility. In addition, we've been working very, very closely with BWXT through a partnership there where we bring a lot of their know-how and historical capabilities with TRISO and bring some of our unique development manufacturing and laboratory facilities to really push the envelope of how we can drive up the economics and drive down cost around fuel, because that will be important for our customers moving forward, and having a very solid story about how we can come down the learning curve and make TRISO affordable is very central to our development paradigm. I mentioned iterative development and the engineering test unit series. We have what was called our engineering test unit 1, which was performed in Albuquerque. It was completed and decommissioned in 2024. One of the nice things about the engineering test unit series is it allows us to go through the full life cycle all the way through D&D, not just running facilities, but also how do we take them apart in a more affordable way. We're about to be commissioning what we call our engineering test unit 2, where we brought in a lot more of the modularity. How do we plan to build these commercial nuclear structures? We believe very strongly in modularization and standardization. The modularity approach we have is a little bit different than we saw with the large Vogel project. We are decoupling the superstructure from the equipment. And then last but not least, in Tennessee, we have what we call our engineering test unit 3. This is a high temperature, high rad environment. So we have to have the ability to do remote handling and remote operations and maintenance. Our customers care about that. So we're standing up a training facility where we're standing up those capabilities in Tennessee. I want to make sure I'm respectful of the time here. Um, So just really quickly getting into how we view building, the title of my presentation is Building What's Next. This thesis, a lot of developers are looking into how we do this. Excuse me, pardon. How do we bring in a factory environment into really the construction field? There's a lot of waste, a lot of dependencies if you look at a linear schedule in a typical construction site. So to bring high efficiency to the construction site, we believe there are some central tenets to our design that are important. First and foremost, the ability to isolate the superstructure from the ground. That enables a lot of opportunity around standardization. Because we're a low pressure, high temperature system, we believe it opens up some innovative technologies. Precast concrete is used commonly for accelerated building. That's not unique, but using it heavily in the design in construction really opens up opportunities to parallelize the work and get great efficiencies. The erection of precast structures are breathtakingly quick. And if you're waiting on very large cast and play sequencings with large inspections, it really opens up a lot of opportunity. You combine that with our experience from modularization of the equipment and what we've done through the engineering test unit series. We believe that opens up opportunities to accelerate the overall construction and then standardize that approach. And it's very scalable when you look at building in different parts of the country and then more broadly globally. So there's a cute video here that shows some of that quick. It's a lot easier when you look at the video, for example, but this really drives a lot of how we're designing the structures. And I'll close here. The Hermes 2 demonstration plant. Commercially, it's important that you have the right commercial agreements. We have a 500 megawatt master plant development agreement, which we signed with Google. Hermes 2 is really that first deployment in that commercial series. And we have an agreement with TVA to supply up to 50 megawatts to the Tennessee Valley and Alabama as well. So we're very excited about moving forward with that. And with that, I will close my presentation.
Ed, thank you so much. I really appreciate it. I look forward to asking you some questions when we turn to the panel, and we will move to our next speaker. Before I introduce Roger Martella, I did take a chance to look at the chat. I want to thank all of you for checking in. Those who did not check in, please do so. I see friends from all around the world. I see people who always join us on our events, and I know that you will have some great questions for our speakers. So please make sure you're checking in the chat, and please make sure that you're adding your questions for our speakers. Next, I'm going to move to Roger Martella. Roger is the Chief Corporate Officer, where he serves on GE Vernova's executive leadership team, and in addition is the head of Global Government Affairs and Policy and Chief Sustainability Officer. In this role, Roger engages in the world's top public and private sector leaders for energy affordability, reliability, security, and sustainability. Prior to joining GE in 2017, Roger served as General Counsel of the U.S. Environmental Protection Agency under the George W. Bush administration, where he was unanimously confirmed by the U.S. State Senate, and as principal counsel for complex litigation for the Department of Justice's Natural Resource Section, where he won every case he litigated. Roger is a life member of the Council on Foreign Relations and serves on the boards of the Atlantic Council, the Clear Path Foundation, the American Conservation Coalition, and Center for Climate and Energy Solutions, among other energy and environmental NGOs and think tanks. Roger is also a wonderful friend of the Department of Energy, always shows up at everything we do, and we greatly appreciate your support, Roger. I will turn it over to you.
Aleshia, thank you very much. Thank you for the honor of inviting me. We're here to serve you, just to be clear, because your success really matters. And we're just so thankful for you and for the nice future initiatives for everything you're leading. None of the things I'm going to talk about I could talk about without you, just to be clear. And I'm happy about what we're going to discuss here, but none of it would happen without the partnership that you and others are leading at the Department of Energy and the Nice Futures Initiative. And I think the way this conversation today is so interesting with the different speakers, because we all have a story to tell as part of the overall theme on the commercialization of SMRs, but we all have a little different story and the way they fit together. So I'd love to go to the next slide and maybe share with you where I think we fit into the story of today's discussion. The role for the technology we have at GE Vernova, our BWRX, is an important role, because in addition to providing nuclear electrons, which is the goal of everyone on this call today, and more nuclear electrons, is I think the role we're going to play when we talk about commercialization is we get to go first. And all the technologies today have opportunities and advantages, and we think they all have a role to play. And our role is, I think, in a way, not only important for the BWRX, but it's important for the whole industry, because what we're trying to do is prove out that these technologies are viable, they're technologically viable, they're viable from a construction standpoint, they're viable from an operational standpoint, they're viable from a financial standpoint. And so we are going first, I think, in a way, and that's important for us, but we think it's important for everyone else in this call and all the other technologies, and for the Department of Energy and everybody who cares about these topics. And I want to share with you a little bit of an update on kind of how we're doing, what we're doing. I'm going to maybe just share some pictures, because I always think a picture's worth 1,000 words, and we have some fun pictures to share with you. But just a little bit about what do I mean by that, and why do we go first, and where do we fit in this story, why that's our role. So years ago, when we were looking at, as a longstanding nuclear company, and I know everyone on the phone's more of a nuclear expert probably than I am, but you're familiar with the BWR, our boiling water reactor. We were looking at, the possibility for a nuclear resurgence. No one was betting on it at the time, but we thought it was a possibility. And what we thought the world would need, if that were to come to fruition, which it has, is it would need an evolutionary approach first, perhaps before we get into the revolutionary approaches. And we welcome, the FHR and ED and the more revolutionary approaches. But we thought the world would need kind of a middle ground. And that's what we pursued, which was a little controversial at the time. Some people might have pushed back on us and said we weren't being creative enough, we weren't thinking outside the box, but we thought that this was a necessary step. So if we go to the next slide, what you'll see is we basically took our existing technology, something that to any nuclear expert engineer is near and dear, and they can look at it and understand it, the BWR technology. And the X stands for the 10th iteration. So it's the same fuels, the same design, the same technology. It's modularized, it's shrunk down into 300 megawatts. And this is my theory of kind of why we took this evolutionary approach, because we thought that's what the world would need. It would need to move first on something it was familiar with and understood, and then that would then open the door to other technologies as well. And I think that theory that we adopted years ago, which was controversial, it wasn't always popular, and we were on defense. I was on defense a little bit and trying to explain it. I think it's been proven right. And I think we're seeing that response in the world, because we are moving forward on construction. We're moving forward with opportunities all around the world, because I think the world is looking for the world's, I think, in a risk-off environment at the moment when it comes to nuclear. And that's a little bit what I want to talk today, is how we're managing the risk, because it's not like we are risk-free. People are even looking at the risk of our technologies, but they want to kind of establish that framework in the near term, and that opens the door to the longer term. So let me share with you what I mean by that. As I said, a picture is worth 1,000 words. I'll move to our next photo, please. This is something we're very excited about. So if you were to go to Ontario, Canada today, you see about 400 people working off of Lake Ontario, building the first commercial SMR anywhere in the Western world. It's our BWRX. And we started construction around, I think, May of 2025. And this photo was taken about a year later in April of 2026. And what you see with that big crane and what it's attached to is that's lowering the base plate into the nuclear vessel. And so starting in May of 2025, we started the work. We excavated the 38-meter pit. We built all the infrastructure around it. And then in April, when we constructed and lowered the base plate, we now officially have a nuclear power plant under construction. We are now in nuclear construction mode. And we think that's very exciting. And It'll be commercialized. I'll walk through some timelines with you, but we talk a lot as we talk about commercialization. We talk, how do we get steel in the ground? That's the goal, right? We know when we get steel in the ground that we are moving forward, that this is no longer hypothetical, it's becoming a reality. And this is more than steel in the ground. I used to say we had concrete in the ground. We have more than that. Now we have the nuclear concrete in the ground. And by the end of the year, we will be above ground. So I don't know how I'm going to describe it then, but I think that's another cool milestone, that we will be doing above ground construction towards the first SMR to be commercialized in the Western world. So just to share a little bit more of where we're at, if we go to the next slide, because I do want to hit this point that this is no longer hypothetical. This is really happening, right? Not only are we under construction at the site and progress is being made, the supply chain is up and going. The long lead time items, the turbine building foundation, the base mat that we spoke about, getting the control room simulated and working in all the marine work. So this is all the pieces are coming together. And so the lessons we're learning on the first SMR are lessons that we're sharing with the Department of Energy in real time. We're sharing with NRC, we're sharing with other stakeholders all around the world, even other companies, so that we can learn from this. Because I think while it's great we have construction for one SMR, no one thinks that's enough, right? No one's going to be satisfied with that. This is all about commercialization. How do we accelerate and so on? So if we go to the next slide, a little bit about what's to come here when it comes to Ontario. I just want to share an update. We're looking at 2029 for completion of construction. We're on track for that. I think, in any construction project, some things move ahead, some things fall behind. I'm sure there's a bit of that day to day, but we're optimistic about the schedule and then the connection to the grid in 2030 when we start delivering those nuclear electrons. So that's the first of its kind, and that's a little bit of why I say the role we play in the story is to go first, both for ourselves and to open the doors to others. But we don't stop there. So let's just talk about where does this translate into other opportunities, and we'll chat about the U.S. We'll chat a little globally, I think, on the next slide, and then focus down on the U.S. and the work we're doing with DOE and Aleshia. So globally, a lot of interest, a lot of questions, a lot of inquisitiveness about the BWRX, and this is a little bit of how many calls and discussions and meetings we're fielding. We're very happy to share information, but we're also trying to be very strategic in the deployments. North America is doing quite well thanks to the current policy environment. I'll double click on North America here in a second. I'm in Brussels right now. I think we jointly see kind of Europe as the next strategic place to deploy. I think the industry's strongest when we have North America and European Union roughly working together and sharing, success, sharing supply chain, sharing information and things like that. So I think there's a strong focus on there. But Middle East and Asia also closely, trying to move at pace as well as other parts of the world. So we're trying to be very strategic as we deploy these technologies. How do we get the most leverage for the good of everybody? And how do you commercialize this the quickest at scale? Now, in terms of the US, if we go to the next slide, beyond the work in Canada, something that's just been a real deal, a game changer, I would say, has been the work that Secretary Lutnick has done with his counterparts, as well as with Secretary Wright, to focus the relationship between Japan and the US on deploying SMR technologies for the benefit of both countries. We have the fortunate opportunity to be in a joint venture with Hitachi, a very proud Japanese country. And so as the US and Japan look to resolve their trade issues, both countries have been extremely enthusiastic about how do we build a nuclear economy, a nuclear renaissance for both the United States and for Japan. So working closely with the Department of Energy, the Department of Commerce, and our friends in Japan, we have continued to make progress on kind of a very historic opportunity that's been announced by the president, $40 billion for 10 SMRs, a TVA in Tennessee and Alabama. And what we're working through a lot is not so much the technical issues. We've kind of been through the due diligence on the technical issues. We're working through the types of topics you would want to be working through, which are cost overruns and risk and finance and permits and things like that, because this is really a first of its kind kind of project, even if it's not a first of its kind technology. And so the precedent that this is doing by accelerating, I think this is accelerating the deployment of SMRs by 5 years, is also going to pave the way. It's not just the technology, but the types of policy, financial risk issues we're resolving now. will make the road clearer, I think, for everybody else. These are hard issues, no doubt about it. I think this is harder than, frankly, the engineering part of it. But thanks to the partnership with DOE, the Department of Commerce, and our colleagues in Japan, we're working steady at resolving them in a lot of creative ways that we'll look forward to sharing. And then just in terms, I think my final slide here, if we could turn to that, please, is beyond just the Japanese partnership. TVA has been a strong partner as well. We look forward to the permit pending at NRC for Clinch River. The Department of Energy has supported TVA and these projects with a $400 million investment funded by Congress. And just, the strongest possible partnership, Aleshia, reflected on my career going all the way back to the Bush administration, actually even the Clinton administration. I don't know if I've seen a better example of 35 years in Washington of so much alignment and partnership between so many different government stakeholders and private sector stakeholders than on this topic. I think everyone knows the stakes are high, everybody's watching, and we have to be creative, not only for the success of the BWRX, I certainly wanted to succeed, but really for the broader success and the message that's going to send for others that these technologies are not hypothetical, that we can get over the hard stuff, both engineering and kind of practical when it comes to rolling it out and succeed together. So I look forward to any questions on that or discussion with the group, but thanks for giving me the chance to share that, Aleshia, and share those updates.
Thank you so much, Roger. Really appreciate and look forward to have the opportunity to talk to you at the panel. So our next guest speaker is Dr. Lou Martinez Sancho. He is the technology officer at Westinghouse. He leads the company's global research and development portfolio and advances the company's innovative product and services technology strategy, advancing AI. He also supports the AP300 small modular reactor development and the eVinci microreactor technology for space and defense markets. Dr. Martinez Sancho brings more than 20 years of experience to this role, having worked in senior leadership positions in energy, biotech, automotive, and architecture, engineering, and construction industries. Most recently, Dr. Martinez Sancho was Executive Vice President of Strategy and Innovation at Kairos Power, with additional oversight of the supply and procurement and marketing and communications teams. Previously, she served as the Chief Innovation Officer of, we hope we get this right, SPY Bagtanolis, and Vice President of Global Innovation at Firmatom. Dr. Lou Sancho, please, the floor is yours, and thank you for joining us today.
Thank you, Aleshia and Holly, for inviting me. This is a very exciting webinar for people like myself that we have been trying to work to build a new nuclear in the grid. So thank you to DOE, to the NICE initiative, and of course to the National Laboratory of the Rockies to organizing actually this exciting webinar. I think what it had been said during the starting of this is that the world is asking for two questions at the same time: how we are going to power the AI revolution, and secondly, at the same time, how we are going to decarbonize at a scale. And the answer is that we need to do both at the same time, and that's why all of us we are delivering nuclear. I will echo Roger what he's saying, that the opportunity is that large that everybody really has an opportunity. I know what is going on with the slides. This is just the last one. I think we need to go to the first one if possible. I guess we're having some technicality issues here, but I will keep going while the right slide will appear. So what we have seen is that the challenge is no longer whether nuclear works, it's really where we can build it fast and predictable enough with repeatable or enough to meet the moment that is required. Today, I want to talk about what is the contribution of Westinghouse and what is the challenge, what we thought and we call the APX platform. A platform strategy that combines the proven technology from the APX, that is advanced passive safety, it's a generation 3+, as well as artificial intelligence from the concept to commercialization. For me, what is very clear is that the future of nuclear is not just reactor by reactor, as we have seen in the previous generation of nuclear in the 70s and 80s, but it's about a platform that actually can scale up whatever technology that is needed for actually the market segment that is appointed. If we can go to the slide 2, if we can see it. Thank you. Westinghouse has been part of every major chapter of the nuclear energy. We built the first commercial pressurized water reactor in Seeking Point in Pennsylvania. And today, Westinghouse technology support roughly half of the world nuclear power. This is what we are seeing on this slide. And we are very agnostic around supporting the licensing, supply chain, operations of many plants. And we are also supporting, as an engineering company, some of the technologies and other SMR vendors that they came to us for support, saying, hey, how we scale up, how we build actually a supply chain, how an OEM works. And as I said, really on everything that is services, we are very agnostic on it is. Then we have our own products, and it's what I'm going to talk today and what we are building and how those products are being developed. So we can go to the next slide. And I know you're expecting, I will expect to talk about the AP300, but this philosophy that we have in Westinghouse, the logic behind AP1000 and AP300, it is the same technology platform. So this is the approach that we have to new nuclear plants, and it connects the AP1000 and the AP300 through common engineering learnings, supply chain experience, digital tools, technology bricks, and I will present a bit about this. Even the Vinci, that is a fully different technology, is heat pipe, a combination of heat pipes and TRISO is a microreactor between 1 mega, 5 megas, depending what the market needs, is benefit for the lessons learned of this APX platform. We are in a unique position here because the APX platform is the entire plant design is fully frozen, is fully digitalized, is fully modular. I know people sometimes don't think about large reactors or having a modular construction. It is the case of the APX platform. And when I say fully digitalized and that the design is frozen, it means that individual wires, termination, pipes, support. We saw the great picture, and congratulations to our colleagues from GE, where we will see what it means actually construction. We have faced that a number of years ago. We know that that is the hard part of the building, but if the design is not fully standardized and fully digitalized, it's very difficult to utilize other tools to allow you on the execution, but also later on the operations. So AP300, that's why it's a bit different. Maybe you see us a bit less out there communicating about the AP300, because what we do is we present to our customers our APX platform, and then the market chooses, do I need gigas or do I need megas? If what I'm looking for is the value of PWR that has been proven, has been already developed. So that's why everything, when you're hearing about AP1000s, how the government is helping with the LLIs program, when the executives were out and we promised President Trump that we will support in the United States the executive orders with a PAC-10. That can be also complete, obviously, with AP300 that are providing part of this new developing model, utilizing the lessons learned of 6 AP1000s worldwide already operating with really amazing backgrounds. So AP300 is not under development. It is the same platform as an AP1000. And we keep improving the delivery model. So that's why we keep working with AI tools that I'm going to present just after, and integrating all the lessons learned that we have on the AP1000 on standardization, modularization, supply chain, and basically executing around the world, and now also operating those plants that help us to review some of the concepts on the design itself. So if we can go to the next slide, we can see how we innovate in a technology that is a generation 3+. So this innovation is connected directly to the deployment and the industrial model. As I mentioned, a lot of these technology bricks, they are agnostic, and our focus is to reduce time, reduce costs, improve quality, and also the workforce upskilling is very critical to us. So the goal is to cover this R&D in a way that allow us to develop these industrial park platforms. So those Pack 10 reactors and the AP300s that they come to complement the customers that they are interested in our technology, it is very different in how Vogtle was done or how the first of the kinds were done in China. So we are really building a full industrial platform where LLIs are starting to be manufactured first. That is the support that we're getting from the DOE EDF program, and we're tremendously helpful for that support. Of course, there are also other discussions, and I know this might seem a bit different because when you have a mature technology that is ready to deploy, for us, what is more critical is the supply chain, is the workforce upskilling, and those are the programs that has been tremendously supportive for us, collaborating with different parts of the DOE, but also at the US government. And I know when you are more in a development mode and you're starting the risking, you need support in other areas. So how we are delivering and what is the basis of our nuclear industrialization? So it's basically a lot of AI that we are introducing. We can go to the next slide. We have developed in Westinghouse in the last 5 years, Hive and Bertha. What is Hive and Bertha? Hive is a nuclear-specific artificial intelligence platform. If you see the APX platform, because it's fully mature, fully developed, already built, we have digital platform that is also preparatory to Westinghouse. We call it WNexus. And because we have all that data and we have 75 years of operating experience, we've been able to develop this amazing tool that is really for nuclear applications. I know there are other colleagues on DOE today also announcing Genesis and other programs that we work with other national labs as well. We are part, of course, of those programs as well. But basically, Hive is the infrastructure. We are positioning ourselves in the full stack of AI. So it means that on the IT perspective, we own the stack that built that AI. And then we have Bertha, that is our generative AI assistants that help us actually to the risk, including constructions. Of course, I'm aware that AI will not build reactors on its own, but AI will help tremendously to the risk, the 60% of uncertainty that is still remaining on the construction piece, even in a reactor that is already fully designed, fully licensed. This is the part that we need to keep developing. If we go to the next slide, I will explain you how we do it for the AP1000s. I will go to the second line. So basically what you're seeing there is a picture of the digital twin of an AP1000, if I can call it like that. We partner with technology providers like Google Cloud to build a very sophisticated tool that we call the de-risking nuclear construction. How it works? Basically, when you are on peak of constructions is where you are seeing on the first image, and our colleagues from GE Royer, you present a very similar image, you know what it is. You can have like thousands of workers at the same time building actually, even if it's modular, you still need to assemble the models that are coming on site, and that creates a lot of coactivity. What happened in real life? Even if you have predict everything correctly, well, you are a supervisor on site, a wire or a cable does not arrive on time. What includes, like, probably you can have 1,000 employees not knowing what to do. Not human brain can adapt that planification and the risk associated with the whole certainty on the cost and the schedule without help. So this tool is fully linked with our WNexus platform, and basically it's a decision-making tool that helps the supervisor to say, hey, if you cannot accomplish these tasks today, this is actually what we can do instead, so you can keep actually on track the cost and the schedule for the overall planning. We have utilized this very sophisticated AI. We're very grateful to work with our colleagues for Google Cloud. The basis of our infrastructure in Hive, we are partnered with Databricks, and we utilize a lot of the capacity on the cloud from Amazon, Google Cloud, and of course, as well, Microsoft, that is our main provider of of cloud that allow us actually to develop these distributed tools. This creates what we call a digital thread from design, licensing, procurement, because all our supply chain can actually connect into the platform and can utilize these sophisticated AI tools to be sure that we can master the delivery. From the commissioning and the operations, we are also utilizing them. The Vogel projects were impressive. The learnings between Vogel 3 and Vogel 4 on the commissioning piece is we don't see high risk, but we are working a lot on the construction piece and also being sure that the shipyards that they are working with us on building those LLIs and the suppliers building LLIs, that they are getting and building that digital continuity that will allow us actually to deliver on time. For the AP300, it's exactly the same methodology. What is the difference? Is that AP300 is a fast follower of the AP1000. What it means is that it can get all the lessons learned from it and is fully AI engineered. So it means that all those lessons learned where we have uncertainty, we keep reducing them as we are building more on the APX platform. And my last message for today, we can go to the last slide. I will say that if I need to leave you with a message, is that the future of SMR commercialization will not be won only by a technology. It is really about the delivery model. Is the technology that is going to be able to be licensed, built, deployed in a repeat and scalable way. And I think all the companies that you have chosen to discuss today, we are really on that mindset. So proven reactors, frozen and standards designs and supply chains, platform thinking, and digital continuity with nuclear-specific AIs. That is how we are moving from demonstrations into actually deployment and real projects. Thank you for listening.
Lou, thank you so much. Love your energy. And, you mentioned the enthusiasm of the other presenters. You all have really just not only demonstrated how excited you all are about what's happening within your companies and within the nuclear ecosystem, but I love the message that you all are supporting each other and applauding each other for all of the work that you're doing. Because sometimes, I think there's erroneous message that companies are always focused on competition. Of course, there is competition, but there's also, I think, a genuine respect and a genuine desire to see nuclear succeed globally. And so for you all to come with that type of energy, that type of support is so refreshing. And so I thank you for your presence today, and I look forward to talking to you when we go to the panel. So I will move to our final presenter. We are so honored to have Dr. Jose Reyes. He is the co-founder and chief technology officer of NuScale Power. He is professor emeritus and former head of the Oregon State University School of Nuclear Science and Engineering. He holds a BE degree in nuclear engineering from the University of Florida, an MS and PhD degrees in nuclear engineering from the University of Maryland. His areas of expertise and publications include system scaling analysis, reactor thermal hydraulics, passive safety systems, and small modular reactors. He is a co-inventor on over 180 patents. That's the one fact I always remember about Dr. Reyes. Pending or granted in 20 countries, and the recipient of several national awards, a NURETH Fellow, a Fellow of the American Nuclear Society, and a member of the National Academy of Engineering. Dr. Reyes, I have had the pleasure of seeing you speak multiple times. I love your energy and passion, and I'm very honored to turn the floor over to you.
Thank you so much, Aleshia. This is really an exciting event. It's really a turning point for nuclear worldwide. So globally, we see so much interest in using nuclear power because of the fact that it's clean and that it has a very reliable fuel supply. I'm going to talk a little bit about our technology, but I'll also talk about how we're going to innovate our energy future. So more than just putting electrons on the grid, we're opening the door to whole new markets. So let's go to the next slide. We've been working at this for a while. I co-founded NuScale back in 2007, so it's been a while. And pretty much all the hurdles, the regulatory hurdles related to getting our SDAs, those are all done. We've got two NRC approved designs, standard design approvals, the 50 megawatt and the 77 megawatt. We are near-term deployable. We have 12 modules that are in production. I'll show you some pictures there. We have an established manufacturing ecosystem, and over $2 billion have been invested to date to really de-risk the plant licensing, the operation, the manufacturing. Really, that's been used wisely to move us forward in a big way. And as you mentioned, we have lots of patents. So it's been an interesting journey. What's exciting to me is where we are in terms of flexibility and ability to address new markets. But I'll start with the design of the reactor just first. So next slide, please. This is our technology. It's very, very simple. It includes the reactor vessel, which is in the center, that's housed by a containment vessel. So instead of the large concrete dome that you typically think of for nuclear power, we replaced that with a small containment vessel. So what's unique about the design is that we manufacture the reactor vessel, all the internals, and the containment in a factory. So it really simplifies the deployment of our what we call our NuScale power modules. Each power module produces about nominally 77 megawatts electric, about 250 megawatts thermal. You can see the length is about 22 meters in length, 4.5 meters in diameter, and it's all fully fabricated. So it's a different model for deploying nuclear power. Wherever we could, we used existing technology. We want to leverage the existing supply chain for light water reactors. That's not the novel part. We tried to use the same materials, the same fuels, commercially available fuel, low enriched uranium. What's really unique about our design is the multi-module flexibility that it offers. So we'll go to the next slide. So we, as I mentioned, we did receive our standard design approval from the NRC. All our key testing programs have been completed. So we validated our design, the performance, and many of these in full-scale test facilities or full height facilities in Italy and in Germany. So we have an established global supply chain. And I mentioned we have 12 modules currently being produced. Not long ago, Tennessee Valley Authority announced that they were looking at teaming with ENTRA1 as our developer to deploy 6 gigawatts of power. So that's roughly 6 of our NuScale 12 module plants. So that's a big move forward. We're excited about that. That's all being negotiated right now. And we also have a 6 module project with RoPower in Doicești in Romania. So that's also moving along. We have developed a new model for how we finance these projects. And I'll talk more about that in just a little bit. So next slide. So some of the things that are different about our small modular reactor. So these are the things that have been approved already. And it's really based on our safety case. For our design, under whatever conditions you can imagine, there's no operator action or AC or DC power required to safely shut down the reactors. In addition to that, there's no need to add water to keep the reactors safe and cool for an unlimited time. So this unlimited coping period is really one of the key things that the NRC looked at in terms of our ability to provide a high level of safety. But it's all passively safe, so we're not using AC or DC power. Because of that, we're the only design currently that has a standard design approval that allows us to have no connection to the grid for safety, which means we could be located at the end of the line. Instead of having 2 independent power sources, AC power sources, we don't have to have any. But we can work well with coal-fired plant replacements because we don't have to have a connection to the grid, or we can just have one connection to the grid. The other feature is island mode, which means that we can power an entire site and any microgrid completely without any connection to the main grid. This offers a huge level of flexibility. So now when we talk to process heat end users, as well as data centers, a lot of them are looking for off-grid power. It's becoming more and more challenging to connect to the grid, get permits for connection to the grid. So this is becoming a very important feature, the ability to just completely operate dedicated to a particular end user. The NRC has already approved our control room staffing. 3 operators can operate 12 reactors safely in our control room. And again, it's because of the simplicity. They've eliminated our requirement for a shift technical advisor. So that position has been eliminated. It's not needed anymore for our design. We have a unique cyber-resistant field programmable gate array technology for our module protection system and our plant protection systems. So these are hardwired chips that are used to control and assess the safety of the plant. And then lastly, we've got a site boundary emergency planning zone that's been approved by the NRC, and we can demonstrate that site boundary EPC is achievable. And again, this is really important as we try to break into new markets where they don't want to be within the EPZ of a nuclear plant. So next slide, please. So really it's a new approach to manufacturing construction, how we deploy nuclear power. So this parallel fabrication and construction is really key. And again, the key thing is the containment. We don't want to be building a containment building around our nuclear steam supply. We want to have that all taken care of off-site. So while you're fabricating your modules, the reactor vessel and the containment, you're doing your civil construction on site. So you go from a 6-year to 8-year type build that's typical of nuclear, down to 3 years, because you build you do all your site construction. You can see in the lower right-hand corner there. You build your building. Once that's done, then you deliver modules, and you can deliver them by ship, truck, or rail in 3 to 5 pieces, depending on the site. And then you start installing the equipment. So it's very different than trying to construct a nuclear steam supply right on site. So we eliminate that field construction of the nuclear steam supply. Next slide. So we've completed all of our validation testing. We've built the top 1/3 of one of our modules to do our in-service inspection and maintenance procedure development. You see in the middle there is one of our steam generator tubes that are being wound. You can see, and next to that is our control rod and drive assembly. The fuel, it's all been designed, approved by the NRC. Our module assembly and disassembly equipment for our flanges, so we can actually perform the refueling in pool. And all of our flow instrumentation has all been developed and validated. Next slide. This is really key. Early on, it was said it's impossible to control 12 reactors from one control room. We've demonstrated this now, and the NRC has validated this. We've brought in crews for training. This is a 12-module control room that we have at our NuScale facility in Oregon. And since then, we've actually developed 12 other simulators, 12 simulators of this control room at universities. So we have 12 universities who are currently training on our simulators. It could be a 12 or 6 or 4, but they have these simulators now at universities, including universities in Ghana, or a university in Ghana, a university in Romania, in Bucharest, and a university at Seoul National University in South Korea. So we're getting a lot of operating experience as these different universities are training up on our systems. So we're excited about that. And it's something that we really do want to offer to other universities so that they can start learning about how these multi-module SMRs work and how they're operated. Let's go to the next slide. Manufacturing readiness. This shows the facility at Doosan in Changwon. I got to visit, got to touch steel, which is exciting. So 12 of the modules are in production now. In the center there, you can see the system that's being used for the winding of the steam generator tubes and some of the manufacturing trials there. So this is an exciting time. For me, it's a dream come true because I got to see it go from paper to steel. So that's exciting to me. Next slide. So we do have an established supply chain. And this is something that we've been working on for many, many years. We had to purchase our long lead items way up front. We started at least 2.5 years ago getting all of our long lead items in place in order so that we can deploy in the near term. The fuel is, like I said, 17 by 17, low-risk fuel we're getting from Framatome. You can see Doosan with the manufacturing, Honeywell for our control systems, Paragon with our module protection system, PAR for all of our module assembly equipment. So a lot of names that you'll be familiar with in the nuclear business. Next slide. So this is kind of the key. After we overcame the technical challenges and we started looking at, well, we want to provide electrons, and that's important. But there's so many other things we can do to help address the energy-intense applications. So we started working early on with petrochemical plants. We did a study with Fluor looking at how to reduce CO2 emissions at refineries. Hydrogen production, we teamed up with, we did a project for Shell looking at hydrogen production. Desalination, we've worked with Aquatech and others. One module can provide 150 million gallons of clean water. I mean, that's just phenomenal. That's something that's needed, that water market. Hydrogen production, one module with high temperature steam electrolysis can produce just under 50 metric tons of hydrogen per day per module. We've done studies on how you balance wind, mission critical facilities. We've published papers on reliability because you have 12 modules. You can get a very high level of reliability depending on the power level. And now, of course, data centers are kind of the up and growing thing, really driving the industry in terms of energy demand. So we've been looking at these types of applications. So next slide. So one of the things we wanted to do is work with oil and gas, with clean chemicals. They need a lot of process heat. The challenge was that they typically, for about 70% of their processes, they need heat somewhere around 500 degrees C. So for a light water reactor, that could be a challenge. So we partnered with Elliott Ibarra. They're a large compressor company here in the United States. And what we learned is that one of our modules, coupled to their compressors, could produce about 400,000 pounds of steam per hour at 1,000 psi and 500 degrees C. So we find that these are very efficient heat generating machines, and we can reach the levels and the temperatures, the flow rates and temperatures that are very, very helpful to the process industry. So one of the things that we're doing in the next slide here, I'll show you, is we're going to demonstrate it. We're building a commercial scale compressor at the Elliott Ibarra facilities at Jeannette, Pennsylvania. When we build it, we'll do a demonstration. We'll invite the oil and gas industry to come take a look at this innovative compressor. And after we're done with the demonstration, our goal is to get it field tested at a petrochemical industry partner. We have joined the IANC. So this is a group, a consortium that was founded by ExxonMobil, by Shell, ConocoPhillips, Rio Tinto. Is a whole group of oil and gas industry folks who are really looking for clean energy. But it has to be at scale, and it has to be economic. So this is what we've been working on as a kind of a separate market from just the power generation. So next slide. I just want to take a minute to talk about the ENTRA1 energy model. As we talk to the oil and gas companies, as we talk to data centers, we had a common theme. They said, we don't really want to own and operate a nuclear power plant. And we just want the power, we just want the steam. So that's kind of a recurring theme. So this model allows ENTRA1 to finance the entire project. They build a team with the EPC, architect, engineer, NuScale, the construction groups with the EPC, and they organize all of that. And then they'll bring in a nuclear operator, a well-known nuclear operator, so they can do the whole job working with this team. So they offer a build, own, and operate, or build, own, and transfer. So on the build, own, and operate, the end user just needs to sign a power purchase agreement. And so this is what attracted TVA in terms of the project that they're currently looking at, which they had announced for about 6 gigawatts of electrical power. So not only did we have to innovate the technology and how you deploy nuclear power, we really had to innovate how you finance and get the construction projects going so that they can sign a PPA for the different industrial users. So that's kind of my last slide there. I want to thank you so much, Aleshia, for inviting me to speak, and I'll turn it back over to you.
Thank you so much. I really appreciate hearing from all the in the 20 minutes we have left. So I am going to ask you to be a bit brief with your answers. My first question to you, if you could tell me at least 2 myths about SMRs that you would like to clarify. And
Size alone doesn't just solve the challenges around cost and deployment. So I would say size is one of them. Modular as well. Certainly modularity is important as part of SMRs, but there's different strategies around modularity that I think different developers are employing. Some are looking at very small micro where they're factory delivered technologies. Our approach is really more around bringing modular build into the factory environment for pieces and parts of the equipment that go into the plant. But I think while they are small and they are modular, there needs to be more better definition around those two terms. So I'll be respectful of others and stop there.
thank you so much. Roger, could I come to you next?
Thank you, Aleshia. You know, what comes to my mind is because we are deploying and we get so many inquiries, is people come in with the proposition like this is a first of its kind situation. I guess you could argue from one lens, it is first of its kind, SMR and so on. But I do think there is a lack of appreciation for the history that got us here, for the evolutionary nature of these technologies. I think that was a theme that ran through all the presentations. And that, yes, while there's new things and we're constantly doing new things, we're not starting on a blank piece of paper with any of this, and we're building on legacy and history, and you even look at the nuclear navy and things like that. So I do find myself having to kind of put things into context that this is not a completely new widget. It's something where we're building on history, legacy to make it better. And I find that's the biggest myth that I frequently run into.
Thank you. And Lou, over to you.
So I would like to reinforce what Ed mentioned. I think, Ed, you are totally right. One of the myths on the SMRs is really the size. Everybody thought that because it's small, it's going to be easier. It is not the case. It's still nuclear. I'm going to give the example of an AP1000 that a lot of people forget is the footprint, or actually what is an SMR. AP1000, it is 2.6 square meters per megawatt produced. When you translate that into concrete, into pieces, actually it is tinier than some of the reactors that we're seeing right now on the designs. And the second piece, this is coming because I spent almost 10 years of my life in automotive and manufacturing. When I hear my friends and colleagues from the nuclear industry, oh, and everything is going to be solved because it's going to be produced in a factory. I say, good luck, because our designs in nuclear traditionally, they don't follow that kind of design. A bit is what Kairos is doing. It is just basically developing as well the infrastructure to actually develop that. It's what we have done in Westinghouse as well. When I talk about W Nexus and AI and all that, that is actually how the automotive, the aerospace, they go industrialize and they build big components and they assemble them. So it's not about the design itself, it's about all the system around it that allows you actually to deliver the technology.
Thank you. And Jose, over to you.
Yeah, no, that really resonates quite a bit. I think, well, in terms of myths, the one thing I think is that I keep hearing this. Well, SMRs are decades away from being deployed. You know, they're just so far off, and you get customers who will use that kind of as an excuse. They lump all SMRs together, and some are still in development, and that makes sense. But for NuScale, we've overcome all the big hurdles. We're ready to deploy now. So getting the bankable project, I think, is more the challenges these days. But yeah, I think that's a big one in terms of myths that could be overcome.
Thank you so much, Jose. I'm going to piggyback off the last statement you made, because a lot of countries have the question of what makes a bankable project. So what I want to ask is that each of you give me one, I repeat, one thing that makes a bankable project. And Jose, since I still have you on the big screen, I'll go with you and then continue on.
Yeah, I think what you really need is someone with a strong demand, a durable offtake, someone who's going to be there for a while. You don't want someone just to build something and then 3 or 5 years down they fold after signing a PPA. You want something that's going to be durable. You want to have clear financing and a very clear allocation of risk. So the customer knows what risk they're taking. The EPC knows what risk they're taking. The nuclear vendor knows what risk. That very clear allocation of risk, I think, is important. So that makes for more of a bankable project.
Thank you. Roger, could I go to you?
I just pick up on the last thing Jose said about risk. This is the experience, that, as I said, we're managing some discussions in real time to commercialize this. And there's many conversations on the table, but the one thing I've come to appreciate is people may love nuclear technology, they may love all the benefits of it, but no one's going to take an ounce of risk that isn't predefined or responsibilities. So we can talk about financing and all these other things. You can solve for anything, and you can solve for risk and responsibilities, but you're not going to solve for a project if you can't solve for the risk and responsibilities. You're going to have to be very clear, very specific, bottomed up, no exceptions, nothing left unaddressed. That's where we find ourselves in 2026, is a lot of motivation, but no one willing to leave an ounce of unsettled risk or responsibilities unaddressed on the table.
Thank you so much. Lou, over to you.
So for me, Aleshia is really the mature design. Fully frozen design, and also thinking on the design and how you're going to manufacture and scaling it up. Because at the end of the day, when you're sitting with bankers, when you're sitting with customers, it's about risk allocation, as Jose was mentioning. And if the design is not ready, having that risk allocations discussions is very tough. And at the end is the square meters of concrete and steel that you need to be very clear, because that they don't go down with the learning curve. You have them. Is the other aspects of the projects that they go down. So to be bankable, you need to arrive with a nuclear power block that is super, super mature.
Thank you. And Ed, over to you.
Sure, I'll just piggyback off the three other panelists because I think they've well articulated the challenges. Allocating risk for first of a kind projects is essential. I would say a differentiator for where we are. Our Hermes 2 project, we are the licensee owner operator of the plant, which means we can't hide risk in different pockets of the project team. We own all the challenges that come along with it. And so by being open about that, I think it opens up future commercial deployments that are a little bit more unique. So I think the project structuring is key. And historically, EPCs have not done a great job of managing first of a kind risk, certainly domestic projects. So I think just having the right allocation of risk within the initial project structuring is very key because it's first of a kind. You can't just go straight to nth of a kind. You have to go through one. So
thank you, Ed. So my next question, and again, I want to keep our answers very brief. What do you see as the biggest non-technical, I repeat, non-technical barrier to deployment? And so just to avoid everyone saying financing, don't say that. Over to you all. I'll start with Lou first.
So this is a hard one, and you put me the first one, Aleshia. So what I see really, it is a combination of things on it. But basically, I know you say, don't say finance. It's really the allocation of risk for me. That because really the regulatory framework, a lot of the companies were here, we've been there, we pass it. It's not really an issue. When you are doing with work, you have a great engagement, even technologies that they are much more disruptive, like Kairos, they obtain the permission applications. NuScale was the first one that opened that to all of us, especially on the SMR work. So it is feasible, there is a path. But when you sit with the financial guys and you need to understand how you allocate the risk and how actually the project with the developers, we have a new ecosystem that is very different for nuclear. It's much more closer where we see in renewals. And that is not a roadblock, it's in our minds because we are struggling to actually innovate on the business model itself. So I will say, instead of saying finance, is the business model of how you're going to contract in nuclear in this era.
Thank you. Jose, over to you.
Yeah, that's really, I think in terms of non-technical, I think those are true. I mentioned that. I mean, the demand is so strong right now. The energy demand is enormous. We have people who want power, but converting that strong demand into these bankable projects, that's kind of the biggest non-technical challenge. So you do need a different type of model for nuclear, which we haven't had in the past. The idea that you can work with non-traditional end users, not just necessarily utilities, but with data centers, with process plants. That is creating a new opportunity, but it also requires dealing with again the how you allocate risk and how they perceive the risk for a project and what they're willing to accept for risk. So right now we have a model where the developer takes all the key risks for construction, and which makes a big difference, I think.
Thank you. Ed, over to you.
Seems a bit unfair to have 3 CTOs up on the panel and ask them for non-technical risk,
Right,
but that's fair. I think what's been mentioned is absolutely right. For us, we have a non-light water reactor, so it's a little bit different. I think one of the biggest challenges right now is moving from first of a kind development to repeatable deployment, and I think that's a risk and a challenge that Kairos is going through certainly right now. You have to go through one to get to nth of a kind, but having a process and a delivery approach that is scalable for repeatable deployment is certainly one of those challenges. So keeping agility while also moving quickly and getting to repeatable, standardized designs. Maybe that's technical, but I'll leave it there.
Thank you. And then last but not least, Roger, to you.
Well, I'm going to be a broken record, and the honest answer is the risk allocation. And I think it just emphasizes how important it is to all of us, is what we're seeing. But just because I know Aleshia is going to want to push for, more than the same answer. I'd say the second thing I'd say is beyond just risk allocation. There's different levels of due diligence, right? And we make different technologies and we see different types of due diligence based on people. Just be prepared that you're going to go through the most extreme due diligence on these types of projects for some time until they become more conventional. And many questions come up in due diligence. One of the questions that's very interesting that comes up is everybody wants these SMRs to run for a very long time, 40 years at least. And if we look at technologies, how do you even predict what's going to be needing this kind of power in 40 years versus what's going to be obsolete and things like that? So that's just an example of a question that investors and developers are going to expect here, because there's just such a low tolerance of risk. They are turning over every rock, I think, possible, as they should, as I would be, as they go through the due diligence process.
Thank you. Now, my next question is going to be one that only if you disagree with what I say do I want you to interject. Because a lot of times in a lot of audience, every single audience, and including the one today, people ask the technology providers about financing. And they also ask about cost. So my statement is technology providers are not responsible for financing. My other statement is I've not met a technology provider yet that has provided in any public meeting the cost of their product. So I do want to just check in with you, since folks have asked, to see if anybody disagrees with what I say, because normally when the question about cost of your specific product is asked, I get the response that you all would love to have bilateral conversations, have NDA signed, blah, blah, blah. So if you disagree with what I say and you want to offer something specific to either one of those questions that are always asked, would you please speak up? All right, that's what I thought. Moving right along.
I may bite a little bit because we are deploying our first technology as a licensee operator for the demonstration. We do care a lot about financing. And so I would maybe push back on the notion that developers aren't worried about financing. From our standpoint, being the first owner operator for our first deployment, we very much care about project financing. And so having a credible path to project financing, getting over that hump to more conventional means of project financing for more commercially mature technologies. And I would say that's true for even light water reactor deployments as well. We very much care about that. So I would maybe push back on that statement and say that matters a lot to Kairos, certainly for our Hermes 2 project.
Thank you. Well, let me make sure that I clarify that, because that was not my statement. My statement was you all don't provide financing. You don't organize financing. So when someone asks the question, what are you all doing about financing? The answer is nothing. You're not doing anything, because that's not your job.
Yeah, we did partner with Entra1 Energy, who is a developer who worries about the financing. So the CTO doesn't doesn't do that.
So
Oh,
Aleshia, for us, we are in a bit different configuration because everybody knows Westinghouse is owned by Brookfield and Cameco. So we are part of the family of Brookfield, and they really care about finance. And they really care for us to be part of those negotiations. And Jose, even as a CTO, I spend a lot of my time with a lot of financial guys, explaining them actually the technology risk, how we can do that mitigation piece. But I know we are in a very particular configuration because we are owned by those two companies, where one is the financial mechanisms for a lot of these nuclear and non-nuclear, of course, energy that they are building on their portfolio. So we are incredibly involved. Obviously, Aleshia, we cannot share that data without NDA and all that, but we're very, very involved with them in those conversations.
okay, thank you. Did anybody else want to jump in? Okay. My next question is, now I'm going to ask you a question where I'm sure that you will not have a similar answer, and that is on the people. We've talked a lot about the technology. Let's talk about people. You are all incredible leaders. You've had multiple positions, and those of you I know personally know that I know that you all are really invested in the people, and your companies have really done a lot of work around that. So my question to you is, for our young people, how would you encourage them to get involved in the nuclear sector? Those who have already studied may not have studied nuclear engineering, but I think part of the messaging is you don't have to study nuclear engineering, but how would you encourage them to get involved? Lou, since you're still on the big screen, I'll go over to you.
Sure. I mean, I will use the example of what we are facing right now in Westinghouse. We have over 300 interns around the world, and it is nuclear, non-nuclear. We really need everything. We do a specific partnership as well with unions, with trade schools, with colleges, because believe it or not, something that we have learned, and one of the lessons learned on Vogel was actually that we were having. I'm sure that we are not going to repeat and quote me on this, but we have too many nuclear engineers. And when you are moving into deployment, you need construction engineers, you need civil engineers, you need welders, electricians. That is the workforce that now we are moving on because the design is already done. So that's why we are engaging with that community. You have seen how even if you have a lot of CTOs in this call, all of us, we are engaging with finance and all that. So people with business backgrounds, people that they think very differently about the business model, that they don't have that background from the traditional nuclear, I think they are more than welcome as well to join us. So there is a space for any kind of discipline. But as I say, for us, it's through that pool of interns programs and the partnerships with universities and labs that where we create actually the workforce to build that. And we support as well our supply chain to be sure they have the right tools, that is not, the nuclear of your grandpa. And that basically, no, if you're going to weld, you're not going to weld in the same way. Now it's automatized and you have AI and you have computer vision and it's fully, it's very, very different and how it was done in the previous ones. And that is what is the excitement about nuclear right now, is that's becoming again a vehicle of innovation. And that's why I love working in technology bricks, that they are very different from traditional nuclear, and bring them to nuclear so we can deliver it. I think that attracts the next generation to come to nuclear as well.
Thank you so much. Ed, over to you.
Gosh, I'm not sure I can add much on that. I fully agree. I think the biggest hurdle is getting over the nuclear sort of technology piece, but recognizing it's a very multidisciplinary, cross-functional, problem. As you've heard, it's not about the neutronics, about the neutrons. I mean, yes, there are challenges there, but at the end of the day, we need very different skilled people to be attacking these problems. And I really can't add anything better that Lou said. So I would definitely agree with that.
Thank you. Jose, to you.
We've always encouraged an outreach to universities and to bring new people in. So I mentioned before, we have 12 of these simulators, like the one behind me, at universities in the US and overseas. And that's a really great teaching tool in learning about SMRs. We about 40% of our company are in their 20s and 30s. So you have a very high energy. When I walk in the office, there's a lot of high energy. That's why you see a lot of patents, because it's not just in nuclear type patents, but chemical processes, how to integrate NuScale plants with chemical plants. There's a whole range of topics that really creates a lot of excitement. And so there's a lot of innovation, and I think innovation really attracts this new generation.
Thank you. And Roger, to you.
I would agree. I mean, not having nuclear qualifications should not disincentivize anyone from thinking about spending the next 30, 40 years of their career having an impact, being part of the future, being part of solving problems. And we see it as such an optimistic future. This is an area to really have an impact that makes the world better. And there's just so many opportunities. The nuclear component is important, but it's a percentage. It's a relatively small percentage of the types of needs we have for the workforce, which I think others have emphasized. So I think it's a broader story beyond nuclear for those who, you know, are looking at their careers and saying, how do I have an impact on something positive? How do I make a difference? How do I help meet some of the world's biggest challenges? This is, you know, it's hard to think of a better space to be in. And I think all of us would love to hear from you, because the demand is outstripping the supply for the entire sector right now.
Well, I want to be respectful of your time. I know you all are super important people. I want to thank you so much. Everybody, show them love with emojis. Show them love. Thank you so much for this incredible panel. You know, my team is texting saying, can we just keep you all as a core panel and just have conversations with you all from time to time. I'm so energized and excited about this. I hope all of you all will join us again. You have been incredible and amazing. I thank you for your participation. I see all the love coming through with the emojis from all the countries represented around the world. You all incredible. I just want to let the community know, nice future. The United States has multiple activities going on, and we have and will invite some of these speakers. Today we have the Asia event in November. We have an Africa event in August. We have a Latin American and Caribbean event in August. And we have a European event in, when is that one? October, I think. At least two of them are at our national laboratories. One is, and the other two for Asia and Africa are in those countries. We appreciate you all. We look forward to seeing you again. Thank you so much to Jose, Lou, Roger, and Ed. You all are incredible, and we look forward to seeing you soon. Thank you again. Bye-bye.
Thank you. Take care.